So just as I promised, I'm making a follow-up video with about this integral, and I'll call it IN. So the goal is to derive a recursive formula for this, and to relate IN to IN with a lower n, in a sense. And then we'll be able to descend and take those steps with smaller and smaller n, since we know I1, which is the 1 over a arctangents of x over a, then we will be able, with the several steps, to derive this, the integral. And so this is quite hard, and this integral is pretty important because there's the theorem about the decomposition to partial fractions of any rational function. So any rational function, which is a polynomial divided by a polynomial, can be decomposed into those building blocks. And this is one of those building blocks which is the hardest to integrate. So let's call this IN minus 1, and I'm going to show you a trick of how to derive the recursive formula, which is not easy at all to come up with. So I'll write x squared plus a squared over here, and I will subtract x squared from here, and here I will write x squared plus a squared to the power of n, and here I will divide by a squared and the integral dx. So if you look carefully, I've changed nothing, because when I subtract x from here and here and divide by a squared, I'm back with the same integral. But now the thing is that when I separate the fraction, then I have 1 over a squared IN minus 1. Yeah, this is the integral of lower order, because here we have the power n minus 1, and minus 1 over a squared, and we'll have the following integral. It's going to be x squared divided by x squared plus a squared, all of this to the power of n, and I'll write x squared as x and x here, and dx. And what I'll do is I'll add a 2 here and a 2 here, so I didn't change anything. But, well, you have already guessed why I did this, because this 2x is the derivative of what we have here, and then we'll take this integral by parts. And indeed, let's see. So if we'll take this to be f, and we'll take this to be g prime. And now if we want to find the antiderivative of g, and we want to integrate g, so integral dx of 2x over x squared plus a squared to the power of n dx. So if we'll make the substitution, I'm just proving it rigorously, it's actually an immediate integral, but, to make it in order to see it more easily. So we'll substitute t to be x squared plus a squared, and then the t is just 2x dx. And then this integral becomes dt over t to the power of n. And here we assume, of course, that n is bigger than 1. Otherwise, if n is 1, then we know how to solve it. At 1, this is 1 over a arctangents of x over a, so we know the solution for this. So we'll assume that n is bigger than 1, so this is t to the power of minus n, so this is t to the power of minus n plus 1 divided by minus n plus 1 plus a constant, or if we want, we can then plug in what we had previously, and then we would have that this is just minus 1 divided by n minus 1. This is the minus from here. And here we have x squared plus a squared to the power of n minus 1 plus a constant. So this would be g. And now when we integrate this by parts, we take the integral of this by parts, then we can write IN equals 1 over a squared IN minus 1. And here we take 1 over 2a squared. And then when we integrate this expression by parts, then this is going to be fg. F is just x. So it's going to be minus x over n minus 1. And here we have x squared plus a squared to the power of n minus 1. Right? And here we're going to take the minus of the integral. So we need to take f prime g, but the derivative of f is just 1. And then we plug this in for g. And we have here minus and here minus, so we'll turn it into a plus. And here we're going to have 1 over n minus 1 here, and this is x squared plus a squared to the power of n minus 1 dx, and this is just in minus 1, and close the brackets. So now if we want to organize it a little bit more, then in is going to be, so this minus cancels out with this one, so it's x over 2a squared, and here we have n minus 1 times x squared plus a squared. All of this to the power of n minus 1, and here we are going to have 1 over a squared, and here we're going to have 1 minus, and here this is just going to be 2. So 1 over 2n minus 2, all of this in minus 1, because of this in minus 1. And if we really want to write it a bit more neatly, so in is x, just for the finalization, 1 over 2a squared, and n minus 1 times x squared plus a squared to the power of n minus 1, and plus here we're going to have 2n minus 3 in the over 2n minus 2 times here 1 over a squared, and this is in minus 1. So, for example, if we were to integrate the x over x squared plus a squared to the power of 2, and so here n is equal to 2. So this is in, right? So here we would have x, and here we would have 2a squared times n is 2. So this is x squared plus a squared, and then we need to take 1 over a squared, and here we have n equals to 2, so it's 4 minus 3, so this is 1, and here it's 4 minus 2, so it's 1 over 2a, and then the integral of this is I1. I1 is actually 1 over a, just the arctangents of x over a, and all of this just plus a constant, and we are done. This is it. So I hope you enjoyed it, and see you in the next video.